So hi everyone. How's everyone doing today? Speak louder. Good. There we go. We're going to be talking about Asterisk testing, specifically the test suite that tests Asterisk and how you guys might be able to use it to test your own stuff. Just out of curiosity, how many people have actually used the Asterisk test suite? Hey, I got a few. Well, Tori, you don't count. How many people have heard of it or know that it exists? Okay, that's not too bad. But before we dive into things, my name's Joshua Culp, also known as File Online. So if you see File in IRC or something, that's me. I'm a senior software developer at Digium. That pretty much means when something like a contribution comes in that has an extra dependency, I'm the one who thinks, hey, there's licensing that might be concerned in that, and then goes off that road. But I still get to actually write code and stuff, which is good. And some of you who have been to AstroCon before might notice that I don't have a hat this year. However, if you look up there, I do have a hat. So please be satisfied by that. And over here is my nice colleague, Scott.
Hi, Scott Grapentrug, software developer for Digium for the last 3 years. I like to mention that if you're curious how to pronounce my last name, because it took me a while to learn how to as well. If you think about the FreePBX mascot, the green tree frog, and then read it how it's written, it actually comes out correct. So Grapentrug is how you say that.
So we're going to be talking about a lot of stuff, but hopefully it does not completely overwhelm you. We're going to be talking about the levels of testing that we actually do in Asterisk, how you can actually use the test suite, installation, how tests are structured. When testing is usually mentioned, people think that turns out to be hard, but we've tried to simplify things as much as possible to make test writing as easy as possible. And also pluggable modules, which Scott will talk about, and then how it's laid out, where logs go, that sort of stuff. So let's start off with test levels. So in Asterisk, we have unit tests. This pretty much covers the stuff that most people don't really think about or know exists. For example, thread pools, which dispatch work to different threads. But we have unit test internal coverage for that. But for this presentation, we're going to be focusing on the functional and system testing, which is done outside of Asterisk, using a Python-based test suite, which we call test suite. And that's really a mix of the functional and system testing. So what gets tested? I don't think a lot of people realize how much stuff we actually do test. So we do channel drivers, SIP, PJSIP, EX2, local, the dial plan applications and functions that you guys use when you're using Asterisk, protocol stuff, so AMI, AGI, ARI. We also test, which is really hard, transfers. So if you do a transfer from your desk phone, we actually simulate that completely in tests, just as if someone was physically doing it. That includes blind transfers, attended transfers, blanche transfers, which are attended transfers that you complete before the other side has actually answered. So some people will do an attended transfer and just immediately complete it. We call that a blind transfer. And then DTMF, DNS, CDR. So overall, we test a lot of stuff. And this came up at DevCon that the test suite's, it's pretty complex of how to get it going. So in the future, we'll hopefully improve that to make it easier to use for people. But the quick start is that you install a version of Asterisk. So if you wanted to, you could go back to 1.8, which is no longer supported, but the test suite will still run against it. You do 11, 13, 14, master if you want. The test suite will ensure that tests that are not applicable to a version don't run. When you write a test, you specify versions. And the test suite exists as a completely separate project from Asterisk. So on GitHub or Garrett, it's called test suite. And you just clone it out. And there are dependencies for it. We rely on some external tools, such as SIP-P or PJSUA, to actually do more of the complex stuff. And then you can run the test suite on all the tests or a subset, and then analyze the results if there's problems. So installation. clone it out like I said. There's some software dependencies that you can manually install, which are mentioned up there. However, we recently created a shell script which will pull down the dependencies for the test suite automatically. So you can run the script and it'll install everything required. And there is also, much like lots of things in Asterisk, there is a wiki page which documents this stuff. So you can check that out if you like. You should just be able to find it if you don't want to copy down that long Confluence URL. You can go to wiki.asterisk.org and type in test suite. And the test directory structure. So when you check out the test suite, there will be an actual test directory which contains all of our tests that are part of the test suite itself. There's a lib directory which has Python modules and extra stuff which help the tests actually run. And there's also a logs directory which, if you run the test suite, all the logs go in there, except for a little bit extra. And then within individual tests, there's a test config YAML file, which is a YAML file that defines the test. And in fact, the entire test can be written just in that. And we'll have an example of that too. Configs directory, which is Asterisk configurations. So if you want to have your own dial plan in there, you can put in extensions.conf. And there's also a SIP directory. Some of these are optional, obviously. You don't need a SIP directory if you're not going to use it. But it contains SIP scenario files. So the test config YAML. Originally, when the test suite was written, we didn't use this approach. Everything was actually done as shell scripts. But as we developed things and we wrote additional tests, we tried to make it easier. So test config YAML is sort of what's come out of that. And it also includes a description of the test. So if someone is trying to figure out what's going on in a test, it'll actually tell you. We've gotten a lot better in recent versions where it's usually step by step. So it does this, checks this. So if someone does run into a problem, it's easier to pick up. And it also declares properties. So like I said, you can limit the scope of the test to specific versions. And you can also define dependencies. It's not, some stuff we don't automatically build in Asterisk. For example, recent addition would be external MWI support. We don't build that by default or really have that enabled. So if you don't have your Asterisk built with that, then the test won't run. And there's also arbitrary tags which group tests together. So one of them might be PJSIP, for example, which tags all of the PJSIP tests. And there's also configuration which covers the lower level test suite stuff which actually performs the test. And this is test object and pluggable modules, which Scott will talk about soon. And a lot of our recent tests, unless they're horribly complex, is just a single YAML file which defines a little bit of constraints, what needs to run, what needs to check, that sort of thing. And this is a basic run test example YAML. So at the top is the YAML version. So you get a summary, description, like I said, properties, and then below it is a shell script version. And so this is a SIP example. How many people are familiar with SIP actually? Yay! So SIP allows you to write XML-based scenario files that speak SIP, basically. You can send a request out, you get a response, you can analyze a response, figure out if it's what you expected, that sort of thing. We use it heavily to do SIP testing, obviously. So I'll get to the good part. So this is actually all a complete YAML file. So description, summary, dependencies, like I said. And then this is the actual test itself. So for a test object, we say we want to have a SIP test case, and these are the scenario files we're going to run. So we give the actual file names and ports to run them on, and that's the complete test. And the test assumes that the SIP scenario file will fail if something is wrong. So if the SIP scenario file does fail, then the test will fail. If it doesn't fail, the test succeeds. So if you're doing basic SIP testing, this is pretty much all you need. Just write SIP scenario, put it into this small YAML file, and the test suite will take care of the rest. For example, like starting up Asterisk, making sure it's running, ensuring the configs are correct, that sort of thing. Scott, why don't you take over here for once? Sure. I've been talking too long.
All right, can everybody hear me? Yeah, there we go. So Python test objects, there's two, if you're not doing the old school, earlier version of the test suite, run test version, where you just have a bash script that's running, then you're running the Python test object method. That's the newer, we're doing everything in Python rather than depending upon a single bash file, bash script to actually give us a single exit return value with the pass or fail. With the Python test, we're not only more flexible. I mean, there's Python libraries for everything out there. You know, all of the Asterisk APIs have Python libraries for them. You know, things like Homer have Python libraries. There's whatever type of interface or something that you need to simulate, there's either a way to go grab something off the shelf that does it already, or it can be written in Python. So Python is very powerful, so our test suite is predominantly using Python. In the modern test suite scenario, the test object, if I go back to, right here. In test modules, we specify what the test object is, in this case the SIP test case in the SIP library file. And we also give it the configuration section to say this is what we want this test to do. The SIP test case is the test object. In other words, the main running Python class that understands what it is that we want to actually test. It actually brings in other subclasses that understand basic to run a test scenarios that also bring in other Python classes such as how we start up an Asterisk instance, so forth and so on. So there's a lot of presumptions that are built into the test object to run the test, which are not necessarily obvious except for the name and the various examples that exist already in the test suite. But a Python test object gives you all these extra capabilities over just running a bash script. It gives you the control of the test sequence with flexible YAML parameters. It is itself flexible and reusable. Again, it's incorporating other classes within the Python libraries in the test suite to bring an understanding of how to talk to different things. So the test object brings in the Asterisk starter object, which brings in the AMI library so that it can talk to the Asterisk once it gets it up and running. And it also has given us, which is really where the power of the test suite exists, the ability to do pluggable modules. So once we've decided what our main controlling test object that's going to run the test is, we can then add in additional extra modules. So let's say that for a particular SIP test scenario, I wanted to have a check to make sure that the right AMI events occurred to confirm that things were going right, or the right CL events. You can do that with a pluggable module. Pluggable module is any one of the Python modules that we have in the test suite that is an add-on. It exercises specific Asterisk features or checks for certain events or adds different test conditions. Maybe we're trying to create some additional stress or do some random hang-ups of some things in order to cause conditions that we're looking for to potentially cause a failure that then we can catch and fix. Existing examples of some of the pluggable modules that we have are event monitoring for all of our APIs, AMI, CDR, CEL, so forth and so on. A DNS server that allows you to actually create a simulated DNS environment if you're testing the DNS of operation of a particular version of Asterisk. This allows us to create a specific DNS environment in the test suite. SIP-P, which we've provided an example of, run the SIP-P scenario. HTTP server, that we may have a need in the test suite for, say, we're testing func curl. We need it to be able to actually go and get something. So you can actually spin up an HTTP server as a pluggable module. Also, the ARI client allow you to exercise ARI functionality, PJ-SUA to do a full client emulation, endpoint emulation, I mean. And also there's a test suite test that allows you to create a simulated database so that the real-time functionality of Asterisk can be tested. This is just an example of some of them. There is a large number of pluggable modules, and every time we need a new functionality, we add another pluggable module. It makes it real easy.
Yeah, I'll focus on one just for a moment that
Sure.
is pretty cool. How many people use RealTime in Asterisk? So a few months ago, we started a project to actually add real-time testing to the test suite. So one of the pluggable modules that was actually added was one that for PJ-SIP, we couldn't exactly do it for Chan-SIP because of the way it's architected, but for PJ-SIP, all of the PJ-SIP tests that we have are dynamically, transparently converted over to real-time, and the same set of tests are run in a real-time environment. So we didn't have to duplicate tests or anything. We just added a pluggable module to do that conversion, to set up the environment, and suddenly all of the PJ-SIP tests that are applicable to real-time, I think there was like 5 or 7 that just, they don't make sense in real-time. We suddenly had real-time testing for PJ-SIP on those tests. So that was quite cool. Tori, you can go ahead. Jared. Go ahead.
So you're saying you're able to run the tests and then somehow rerun the same tests in a different mode. How does that work? Do you run the test with a different flag to it, or what?
So there's a configuration that you can pass to the test suite, which says to run a specific pluggable module all the time. And that pluggable module is executed, which does the conversion from the pjsip.conf file, which is in all of the tests, turns it into entries in a database, reconfigures the environment that Asterisk is going to run under in the test to use that database, runs the test, and then undoes everything it did.
Yeah, but you need to then still make 2 tests, one with that module, one without that module if you want to test both, right?
You don't need to make specific individual tests, because when you're running the test suite, itself, you can pass it a file that. Do you want to speak more? No, I'll just keep talking then. You can pass it a file which can change how all of the tests are run.
I think I know what you're talking about. There is a way of triggering which subset of global config you're going to use. So yes, it's possible to rerun it a second time, enabling the extra test mode.
Run the test twice, and then with this file you say run it this time with the database.
Correct.
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 Yeah, and due to going forward, hopefully everything that uses database access will be written with the foundation that allows this to work. So if we have subsequent stuff which is applicable to real-time, then we'll be able to do the same thing for those tests. So yeah, we now have real-time tests. Yay.
So I mean, that's the huge power of pluggable modules, is that we're able to actually add additional functionality to existing tests just by having some additional code loaded. So pluggable modules are also declared in the same test config YAML that you would put the test object in. You can add as many pluggable modules together at the same time as you need. You can even create multiple instances. So I can have one instance that's checking these things and one instance of the same module that's checking these things with 2 separate configurations. There's no need to write Python code for that if we already have the module. And usually, even if there is a need to put a little bit of code into something, it's usually easy to extend that with very easily into Python to add extra capabilities. An example of what we're talking about with pluggable modules is a ARI originate test that I have here, where we're actually specifying an ARI WebSocket event checker, an AMI event checker, and then there's a second section of AMI event checker that's actually checking a separate set of CEL events, as well as another module that modifies the test by defining when it's going to stop. And the configuration for just one of these, the ARI, actually has a sequence of events. It says match the stasis start condition where we have a particular channel ID, and then send a request into ARI to say, all right, now go ahead and originate that to another, originate this other channel. So in this way, not only am I just checking to make sure that certain events happen, but I can actually chain the next event that I want to issue into Asterisk on ARI to occur because of a particular event that was received. So I'm basically defining all of the things I want to happen in the test in YAML, and all of that's being run automatically with a very flexible Python code underneath. So, I mean, ARI is a perfect example of this, that you can literally create just about any ARI test that you need to do by simply creating a YAML file in the correct format to match what the capabilities of the pluggable module itself is. Occasionally we go into the pluggable module and add a few extra capabilities just because we found something that it couldn't quite do, and there's an easy way to add that. Let's talk quick about custom directory. There is an ability which we actually have customers of Digium that are using this, where you can use the test suite and then graft into it your own custom set of tests. There's a custom directory that doesn't actually exist in the test suite. You're actually able to graft your private repo into the test suite in the tests custom, as test/custom, and provided it's in the standard test directory format, those tests will be automatically found and added to the test suite. So you can add your own private tests and keep them private and have the advantage of all of the pluggable modules and test objects that exist in the public test suite.
Yeah. There we go. The benefit of this is that you don't need to effectively create a fork of our test suite. You
Right.
can just maintain your tests separately and just pull down the latest version of the test suite, graft it in, and you're good to go. If you didn't, you need to fork it, and then if you wanted to keep up to date, you would have to keep merging in changes. So it's quite useful.
We have some examples of some of the more difficult and unique tests that we have. Some very large test YAML configs. I did a check real quick, and I found the largest one was the blinded attended transfers with the dial options. It is a monster test because there's just so many different scenarios that it tests. The runner-up was the ConfBridge test, Triple Lindy. It has 4 different scenarios in it. SIP and PJ-SIP testing, we use a lot of SIP-P scenarios, especially for off-nominal cases. There also are scenarios where we use multiple Asterisk instances to talk to each other. There's even some with some of the transfer and bridging tests where we're using PJ-SUA to simulate an endpoint doing a strange transfer in SIP. Audio qualification tests, this is actually something we've been doing much more recently. We already did have a audio file and amplitude checking pluggable module that allowed you to say, all right, well, we've done a mixed monitor or recording, we've created a WAV file, let's make sure there's actually something in it. Is there some audio in there as opposed to being dead flat? That test already existed. What we've done very recently for the Opus codec, we've added a new test that will soon be actually a full pluggable module that you'll be able to use that does an actual tone generation, run it through the codec, and make sure that it comes out at the other end. So we do tone detection tone generation on one end and tone detection on the other to make sure that whatever codec we ran it through, we got the right result on the other end. And we'll be expanding the codec testing with those capabilities. An example of the custom test suite is internally, as I work on DPMA, we have a DPMA test suite that is in a private repository, and we graft into the test suite in order to do exactly that, to do DPMA-specific tests.
Yeah, and one of the things I'd just like to say, like he mentioned, multiple asterisk instances. In the YAML, you can actually specify that you'd like to have multiple asterisk instances running at the same time. So some of the tests, I think there's probably at least one test I know of that's running 4 simultaneous asterisk instances at once. And the test infrastructure will make sure that they're all isolated, that they can all run at the same time, and allows you to individually identify them, address them in the YAML config. So if you have something complex, for example, you want to do direct media testing, have an asterisk here, have an asterisk here, have an asterisk here, and then chain them together and do all of that. So even for complex stuff where you do need multiple, it's not that hard to use.
So running the test suite is actually relatively easy. Once you've got the test suite cloned out, if you go in the root directory and just type /runtest.py, it will actually run every test that is applicable to the Asterisk instance it finds installed on your machine. If you wanted to run a specific test or a group of tests out of a specific subdirectory in the test directory, because they are organized hierarchical, then you can simply specify the directory path to that test, and it will run either that one or the group. You can also run tests based on a specific tag, and there is a lot of tags and a lot of tests. We currently have 875 tests in the main public test suite, and there are, as you can see on the top 10 test suite tags list, we have 315 for PJSIP. It wins. It was a lot of work to get the functionality there for PJSIP, make sure that things work the same between SIP and PJSIP, and to make sure that things that are different and new that work correctly in PJSIP, we don't break as we're changing code. So there's a lot of tests for that. Yeah.
Slide for a second. What's RLS number 5 there?
Resource list subscription.
Okay.
Yeah, so to clarify on that, resource list subscriptions is a SIP method where you can subscribe to a list of specific entities instead of individually subscribing. It can help some devices that are low powered to handle a large number of subscriptions.
So even though we have tests grouped in subdirectories, for example, there's a tests / channels, / PJSIP subdirectory, that all of the tests designed to test PJSIP are in that directory. There are also some tests that happen to use PJSIP as a part of the test that are elsewhere in the system that are also tagged PJSIP. So if you're doing a run of the test suite with all tests tagged with PJSIP, you're going to get more than a specific directory, which is why we use the tag system. Test execution system, just a quick overview of what happens when you run the run tests .py. First thing it does is it goes through the directory tree and it finds what all tests exist. And it starts eliminating tests that it can't do. If it's not compatible with the Asterisk version you finds, install in the system. If the test doesn't match the tag of the path you've given, or if there are dependencies that are specified in the test YAML, such as, oh, I need func curl to do this test, and you don't have func curl installed in Asterisk. Or maybe I need SIP-P to do this test, and you don't have SIP-P installed. It will actually mark that test as, I can't run this test because of a dependency. And it'll tell you that as it's going through and running them. Once it's gotten that list, it'll then go through and run what it can. And each test is run as a separate process. Either the test run bash script method, which is what we're trying to get away from, of course, or the new Python method, which works a whole lot better. For each Asterisk instance in the Python, it'll create all of the it'll create a temporary path in /temp or var temp, depending upon your installation, and create the configuration for Asterisk and all the paths that it needs. So it's almost like running Asterisk in a change route. So that each instance is, like you were saying, isolated and separate and running. It'll start each Asterisk out of those different directories, and then it'll operate the test. The test object will actually run the test as it specifies in the YAML. Any of the test, any of the pluggable modules has the ability to operate on the test as well as flag a failure if they find a problem themselves. Once the test completion, once that particular individual test runs to completion, it'll shut down the Asterisk and produce the final result, which goes in a log directory. The test logging locations, logs are put in the logs directory out of the root of the test suite. The test suite running process itself writes out a full.txt and a messages.txt, which is a smaller version of what was output from the actual Python code as it was running. So if there was something went wrong in the Python code of the test, that'll be in the logs directory there. If there's something that went wrong in Asterisk, if Asterisk logs something, that will actually be in the temp Asterisk test suite directory. Although there is a mechanism that if a particular test fails, it'll put a copy of the logs from the failed test in a subdirectory in the /logs directory. So if you've run it, if you've run the test suite and you've had a couple of tests fail, the answers are in the logs directory. You may have to go through several levels of directories to find what you're looking for. Knowing what went wrong. So if you've got a test that's failing, the first thing is, well, if you didn't write it, what was this test meaning to do? The test description should have a step-by-step, like we were talking about, description of what that test is supposed to do. You can check the test suite log file to see if there was something wrong with Python. Did the test actually tell you, hey, I expected to see this event and I didn't? Well, now you know why it failed the test. And then you can go into the Asterisk logs and actually look more in depth to find out, well, what was the sequence leading up to that? Do we have any errors that came out of Asterisk, for example, that would explain why it didn't generate that event? The whole point of the test suite is uncover issues sooner. We really require test coverage. If it's mandatory for anything that you want to put code in to the Asterisk code base outside of the master, whatever the next version of Asterisk will be. And we also make sure to run, you want to run the test suite every time you change the code to make sure that nothing else broke that was an unintended consequence. We also make sure with Garrett now to have the test suite tests run, at least a subset of them, on the code change before we have that code checked in as another double check. You want to step in?
Sure. I love talking about automation stuff because that's what I'm doing these days. So yeah, before changes emerged into Asterisk, the tests have to pass. Like he said, we run a subset because running the test suite right now, depending on the system itself, can take a lot of time. So a full test suite run on our nodes can be anywhere from 3 hours to 4 hours. So for merging, we run a subset. We're currently running just the channel driver stuff, so PJ SIP, that sort of stuff. However, nightly, the full does run. So at worst case, it takes a day before we discover something outside of that. As well, we have a variety of systems, and this is just generally good to do. Run it on a variety because every system's different, and it can find problems that another system might not. And that includes platforms, so CentOS, Ubuntu. It's currently CentOS 6 and Ubuntu 14.04, but we'll soon be doing Ubuntu 16.04 and maybe CentOS 7 eventually.
Sure, I'll be happy to help with that.
Yeah, we'll see what we can do. So yeah, that's how we use it. As well, like I mentioned, nightly we also run the test suite against the real-time version, like we were talking about, and yeah, as well, when a change is submitted for inclusion into Asterisk, someone publishes it, says, hey, I want to get this in. We also run the unit test then, which his metrics didn't cover, but we have something like 300 unit tests. Those run much quicker, about 10 minutes. So,
Do you have any questions?
C'est une question? Oui.
Just thinking of migrating from ChanSIP to ChanPJSIP, is there a way for the SIP scenario, so say run the SIP scenario on both ChanSIP and ChanPJSIP, and then so you can detect if you are going to have an issue with migration?
Yes, we do that. We actually have tests that have been, the test exists on ChanSIP and we put it into PJSIP. That's been few because we didn't have a whole lot of tests on ChanSIP, especially a lot of the really odd edge cases. We've been very, very sure to make sure that we have full coverage on PJSIP, simply because, of course, it's the brand new, good thing that. But yes, what you might reuse the scenario file. You would need to create a new test YAML. Actually, you might be able to get away with using the same test YAML, but you'd have to change the asterisk configs. So in the test YAML, in the same directory with test YAML, there's a configs directory, and in that is an ast number, so ast1, and then in that is all your etc config files.
Could you have like an ast1 directory and ast2 directory, one with the PJSIP set up to one of that, and then the YAML say, test both?
The ast1 and the ast2 is actually if you're running two instances of asterisks at the same time.
Okay.
So what you would do in that scenario is you just copy that directory over and say, well, now this test is a PJSIP test, and change up the configs.
All right.
So yes, you would end up duplicating the files, but that's not that big of a. We're constantly reusing parts of a prior test in order to generate the next test, just to make it, get the job done that much faster. There's a lot to test. Every time we put something new in, we really need a test. Also, something I would like to mention, test-driven development. I have several times created the test first and then added the feature into Asterisk to make the test pass. Perfectly possible to do that. Highly recommend it. It's also possible to say if you've got a scenario in your deployment where you've got a particular thing that's causing you problems, or even just so you want to make sure that it always works correctly, you can set up a test that emulates that specific scenario, that specific environment, and then run that regularly, even on newer versions of Asterisk, to make sure that it always works. So you can actually use the test suite. Even if you're not developing code, you can use the test suite to prove that Asterisk is going to perform the way that you want. One last scenario that I've used the test suite for is in debugging problems in Asterisk. We get a backtrace comes in for something that crashed, or a customer complaint that such and such a scenario isn't working correctly. I know there's not any test coverage for that case. I'll go write the test coverage for that case, and I know that at the very least I'll end up with a test that we needed anyway. And very likely what I'll end up with is now something that sets up Asterisk in a very predictable way, and I'm able to tweak the environment a little bit at a time and keep rerunning that without any concerns that artifacts of how I've got my system set up right now are going to sneak into the test and cause it to succeed or fail. That way, by pushing all of that, this is how I replicate this problem into a new test suite test, I have a way of replicating it over and over and over again, so I can trace through the code to figure out where it's wrong in Asterisk. And then once I've got the bug fix for that and get the patch up, we leave that test in the test suite, and if we ever break it again, we know. So that I've done many times as well.
I'd also like to add that if you're writing custom tests and it feels as though that they're applicable to the greater community. Much like Asterisk, the test suite is an open source project as well. We do accept changes against that, additional tests, we welcome them. And if you have any problems, we're here to help. So if you do run into an issue, for example, installing the test suite, then you can reach out on the Asterisk Dev mailing list or an IRC in Asterisk Dev. Or if you're on Twitter, I'll even answer you on the Asterisk Dev Twitter account. I should probably promote that. Follow the Asterisk Dev Twitter account for all the latest Asterisk news.
Patchers are welcome on the test suite too.
All right, other questions? Got two really smart guys up here. Now's your chance.
Run, Jared, run.
For monitoring the system, like with say Zabbix or whatever, like would this be something good to use for that, to keep monitoring all your different connections and make sure the system's operating properly?
Not really. The point of the test suite is that it's going to start from ground zero. It's going to set up the environment for Asterisk to run in. It's then going to set up an Asterisk environment for Asterisk to run in, and then it's going to actually start Asterisk and then run all of the scenarios through Asterisk that it expects Asterisk to do. You can do stress tests. You can have a long running test that is like sliming it with calls and doing
But it won't use the live environment that you're
But
on.
it's not really meant for connecting to a live environment and doing that and doing tests remotely. Now that said, there was a recent addition to the test suite that allows us to connect up to an AMI, allows us to connect up on AMI to an existing running instance of Asterisk and do a particular scenario, but it's very limited in what it can test because it really, your YAML then has to have already been written with an understanding that that system already has certain configuration and can actually accomplish the test scenario that you've spelled out in the YAML.
Okay, so like shell scripting would probably be better in that case.
Yeah, I mean, the point of the test suite is to test specific functionality of Asterisk. It's
Create a CIP scenario file to do that test and then just run it in.
right.
Yeah, it really depends on how you want to test the viability of the running instance. So like George just said, you could have a SIP scenario that's gets triggered at a specific interval, like 30 seconds or something, which sends a SIP invite or another SIP request to your running Asterisk, and then if it gets a response, it's alive. If it doesn't get a response, then it's dead. There's lots of ways to monitor Asterisk.
Okay.
So are you looking to prove that something is either working or not working pass fail, or are you trying to get some performance statistics out of it? Or?
Well, yeah, like at a highest level, maybe just to make sure that your PRIs are up, or you can make an outbound call every minute, just as a test, so you can get ahead of the problem. But then maybe even call quality, you can take it further, like just
Right.
make sure that.
Yeah, there may be some good ideas and some even usable code in the test suite that you could use as kind of a starting point. But the way the test suite is architected, it's really more meant for, I've got Asterisk installed but not running, and I'm now going to fire off a test which is going to do whatever it needs to set up the scenario, check all of the events and things that I'm looking for to make sure that the scenario has passed, and then shut down Asterisk and come up with a result.
Go, Tori, go.
So the Python modules, you have a lot of them now. Is it documented on the wiki, like what modules you have, what are the parameters to configure them, and things like that?
They're not documented on the wiki currently, but there is documentation within the test suite project itself.
It's like a docs directory which says how
I
to use
can't
the
remember
modules?
where it is, but it does have example files for the pluggable modules with the options you can pass from that level.
If you are looking to write a test that does a particular thing, I highly recommend looking through the tests that we have and finding something fairly similar, and then looking at the test YAML to see which modules it's bringing in. if you need a better understanding of what a particular test object or pluggable module can do, again, reference other tests where that's used, or go look at the Python code itself.
Copy, paste, modify is usually my testing.
Yes,
that's
definitely applicable here.
Yeah, that's our strategy too. Why duplicate other stuff? Just copy and paste. Any other questions?
Thank you. So I have a question about security, and I know that test suite's not principally intended for that, but do you have a test, for instance, that checks to see if, let's say, a registration failure occurs, what is output in the logs, and is it the right stuff?
Yes, there are tests for if we force a condition that should fail, did we get the AMI or even ARI event that tells us a security event happened? There are tests for that. There may not be as much coverage as we would like, but I know there is at least some tests that do check that functionality.
As well, if we receive security reports, we'll create tests to have test coverage for the specific scenarios if we can do it.
In some of those PJ-SIP tests, there are probably more tests for off-nominal cases than there are for nominal cases.
Yes, that is the case.
Now's your last chance to ask questions. Otherwise, we're going to have Josh do his interpretive dance.
Take it away, Josh.
No.
Safe answer. Safe answer.
As well, I'll just throw this out there. If you have any other Asterisk questions, don't hesitate to grab one of the Digium software developers. We'll be roaming around still for a while. We'd like to talk to you. That's all.